This is part 1 of the inverse functions videos. We're going to look at inverse operations, define inverse functions, and then write some inverse functions. So inverse operations are operations that undo each other. For example, I can take a number, let's call it x, and then I can multiply it by 3, and I'll get 3x. If I then want to take 3x and undo what I just did, I'll have to divide by 3 to get back to x. So if we're looking at that as a function machine, I'm using the function times 3, and I'm inputting x and getting out 3x. We can think of the inverse operation as the function machine working in reverse. We're going to take 3x, put it into the function machine. It's going to do the opposite of multiplying by 3, which is dividing by 3, and we'll get back out x. Another example of an inverse operation would be addition and subtraction. So let's take y, and I'm going to add 5, and I'll get out y plus 5. If I want to then take y plus 5 and undo what I just did, I would have to subtract 5 to get back to y. So thinking of that as a function machine, I'm looking at the function add 5. I put in y, I get out y plus 5. And if I want to use that function machine backwards, I'm going to put in y plus 5. It's going to do the opposite operation, which is to subtract 5, and I'll get out y. So inverse functions are two functions that undo the actions of each other. This means that the inputs and outputs are switched, which is what we just saw in the inverse operations. So let's use the example f of x equals 4x plus 5. So when I input x to the f function, I get out 4x plus 5 because my function is first multiplying by 4 and then adding 5. So that's what f is doing to x. And if I go and fill out a couple lines of my table, I've got 0 times 4 is 0, plus 5 is 5. 4 times 1 is 4, plus 5 is 9, 13, 17, and 21. And then my inverse function needs to do the opposite. So for my inverse function, when I put in 5, I need to get out 0. When I put in 9, I need to get out 1, 13, 2, 17, 3, 21, 4. So for my g, if that's the inverse, when I put in 4x plus 5, I need to get out x. And when I think about writing inverse equations, what I need to do is think about those same operations as the f function, but doing the inverse of them in the opposite order. So for my g function, I am going to do the inverse of adding 5, which is subtract 5. And then I'm going to do the inverse of multiplying by 4, which is dividing by 4. So my g of x function is to take x, subtract 5, and then divide by 4. Okay, and so we've just written our first inverse function. Let's do an example. So if m of x equals the square root of 2x minus 1, then the things that are happening to x, we take x, which is some number, and we multiply by 2, subtract 1, and then square. So if I want to do the inverse of that, then I need to start from the end and work my way back to the beginning, doing the inverse operations. So m inverse of x is going to take x, we're going to square it, add 1, and then divide by 2, which means that our m inverse of x equation looks like x squared plus 1 all divided by 2. But if I was doing this process and I had more than one x in the original equation, or there were a lot of things going on, I might not be able to use this method, or it might not be the most efficient way. And so we need another way of doing this. Remember when we were talking about the definition of inverse functions, we said that inverse functions have inputs and outputs that are switched. And so if I take this original m of x function, and I wrote it as y equals the square root of 2x minus 1, the input is the x and the output is the y, and so what I'm going to do is I'm going to switch the input and the output algebraically. So I've got x equals the square root of 2y minus 1, and now I need to solve for y. So I'm going to square both sides. I'm going to add 1. This should sound a little bit familiar. And then I'm going to divide by 2, and I get back to that equation. So I can write my final equation in function notation if I need to, but it's okay the way it is. So x squared plus 1 all divided by 2, and that's what we got the last time as well. So let's try a couple. Write the equation of f inverse of x if f of x equals 3x plus 2. So I've got y equals 3x plus 2. If I want to write the output as y, those two equations are equivalent, they're just a different notation. I'm going to switch the input and the output. And so now I've got x equals 3y plus 2. And I need to work in the reverse order to solve for y, and always doing the inverse operations. So that's why this method works. So I've got x minus 2 equals 3y. And to solve for y, I'm going to divide by 3. So if I do that on both sides, I get x minus 2 divided by 3 equals y, and I can write that in function notation. So f inverse of x equals x minus 2 all divided by 3. Alright. Write the equation of g of x if g inverse of x equals the square root of 4 minus 3x. So I like to write this in y equals form to start, and I'm going to switch the inputs and the outputs. Now, it's asking us for what looks like the original function when given the inverse, but the inverse and the original are inverses of each other, so we're going to follow our same process. So when I switch the inputs and the outputs, I get x equals the square root of 4 minus 3y. I'm going to square both sides. I'm going to subtract 4. So x squared minus 4 equals negative 3y. And I'm going to divide by negative 3 on both sides. So y equals x squared minus 4 divided by negative 3. I'm going to write that in function notation, remembering that we were given the inverse, so we're going to write g of x, which is x squared minus 4 all divided by negative 3. Okay, got one more example for you. Write the equation of h inverse of x if h of x equals 3 times x minus 4 squared plus 1. So let's write that as y equals 3 times x minus 4 squared plus 1. Switch the input and the output, and solve for y. So this one has a lot of things happening. I'm going to start on the outside and work my way closer into the y. So I'm going to subtract 1 on both sides. I'm going to divide by 3 on both sides. Square root. and add 4. Okay, so I can write that as h inverse of x equals the square root of x minus 1 divided by 3 plus 4. Be sure to catch parts 2 and 3 of the inverse function videos, and then make sure you do the practice problem set.